Hello everyone, in this video we are going to talk about this simple algebra problem. So what is given? It is given to us this only x1 plus x2 plus x3 plus x4, and this is 1. Okay, so here we need to mention that this xi's they are non-negative numbers, so basically they are bigger than equal to 0. Okay, and then only the square root is defined. Anyway, so x1 plus x2 plus x3 plus x4 given to be 1, and all xi's are bigger than or equal to 0. So equivalently, what is given? So this is given. Okay, in short, you can write summation I equal to 1 to 4 xi, which is given to be 1. The question is, so basically this is the question. The question is, what is the maximum value of square root of x1 plus square root of x2 plus square root of x3 plus square root of x4? Okay, or in short, we can write this: what is the max value of summation I equal to 1 to 4 square root of xi? Okay, well, the problem is very clear. Okay, but before we go into solving this problem, let us first explore this with two numbers only. For example, suppose x1 plus x2 equals 1 is given. Okay, and xi's are bigger than equal to 0, that is already there. What is the maximum value of root x1 plus root x2? Okay, what is the maximum of this expression? Okay, so what does it say? For example, if you take x1 to be, let's say, 1 by 4, and then x2, x2 must be 3 by 4, right? So then what is square root of x1 plus square root of x2? This is simply half plus root 3 by 2, right? So what you get is 1 plus root 3 over 2. Okay, similarly, one can take some other values of x1 and x2. Similarly, one can take x1 to be, let's say, there are many possibilities, let's say 4 by 9. Okay, and then x2 must be 5 over 9, because x1 plus x2 is 1. In this case, what is square root of x1 plus square root of x2? This is simply 2 by 3 plus root 5 over 3. Okay, so what you get is 2 plus root 5 over 3, right? So basically, for different x1, x2, and here you get different values of root x1 plus root x2 here. Okay, so there will be many such values if you keep changing the values of x1 and x2. Okay, always satisfying this, of course. The question is, what is the maximum value root x1 plus root x2 can have, right? So that is the problem. Okay, anyway, so how to approach this problem? Well, this is actually a tricky problem, and we will solve this using something called very famous, something called Cauchy-Schwarz inequality. Okay, Cauchy-Schwarz inequality. Okay, so what is that? What is Cauchy-Schwarz inequality? Okay, so suppose you have vectors x and y. Okay, suppose n-dimensional vectors. So I will write x1, x2, and dot dot, comma, xn. Okay, and y is y1, y2, comma, yn. Okay, suppose these are the two vectors. The Cauchy-Schwarz inequality says, which is of course true for x1, xi's and yi's negative, but here it is given that xi's, suppose xi's and y is positive, that's not a problem. So here the Cauchy-Schwarz inequality says, okay, the Cauchy-Schwarz inequality says the inner product of x and y, okay, and in general, if you take modulus of that, that is less than or equal to norm of x times norm of y. Okay, so what do you mean by that? Okay, so the inner product here, Okay, in suppose we are in the real case, so basically xi's and yi's all are real numbers, so I will not put any bar. Okay, so all are real numbers, no complex number here. So in this case, y inner product is just x1 y1 plus x2 y2 plus xn yn. Okay, since all are positive, I do not need to put mod, but okay, no problem to put mod here. Okay, then this is mod. Fine. And what is norm x? So this is norm x. Norm x is nothing but square root of x1 square plus dot dot plus xn square, which can also be written as square root of summation I equal to 1 to n xi square. Similarly, norm y is just square root of summation I equal to 1 to n yi square. Okay, so this is norm x, norm y, and inner product of xy. So the Cauchy-Schwarz inequality, which is this, the Cauchy-Schwarz inequality says, so if we write here mod of x1 y1 plus x2 y2 plus xn yn is less than equal to summation I equals 1 to n xi square times square root summation I equals 1 to n yi square. Okay, fine. So now to prove our result, actually this required result, what is the meaning, what is the maximum value of the square root of x1 plus square root of x2 and so on, which values of xy you should take. So basically what x and y we should take to apply Cauchy-Schwarz inequality. So that is the main question now. Well, so the x we will take is this square root of x1, square root of x2, square root of x3 and square root of x4, because there are 4 numbers given. Okay, and then y, this is very interesting. What y we should choose? The y you choose here is just 1 1 1 1. Okay, so all are kind of positive entries, and therefore we do not need to care about mods and all. Okay, so suppose x is this and y is this. Now apply the Cauchy-Schwarz, which means what? The inner product of xy, okay, is less than equal to norm x square times norm y, sorry, there is no square, norm x into norm y. Okay, what is the meaning of that? What do we get from that? So what is the inner product of xy? If you know, here the inner product of xy is given by x1 y1 plus x2 y2 and so on, right? So inner product of xy is just square root of x1 into 1 plus square root of x2 into 1 plus square root of x3 into 1 plus square root of x4 into 1. Okay, yeah, so that number, and no need to take mod here because all are positive, and this is less than equal to, okay, summation xi square. Let me write square root summation I equals 1 to n xi square. But in our case, what is xi? The xi's in our case are simply this. If we want to mark here green. Okay, so these are now xi's, right? So what are xi square then? The actual xi's, right? So in this case, xi square is actually xi, because our xi is square root of x1, square root of x2. So we need to consider the squares of them, which is this only. Okay, fine. And then, okay, let me just make it smaller. Okay, times, what should I write here? summation I equals 1 to n yi square, but yi everywhere, all yi's are just 1, right? So I'll just write 1 here. Okay, well, so we are done actually. So on the left, what we have is just xi summation I equals 1 to 4. Okay, and that is less than equal to, what is summation xi I equal to 1 to n? If we go there, summation xi I equal to 1 to n is 1. So sorry, here we should not write n, here we should write 4 only, because we have only 4 number in this particular case. So 4, and we know that summation xi is actually just 1, so square root of 1, and here what we get, square root of 1 4 times, so basically 4, right? And that is nothing but 1 times 2, which is 2. Fine. Okay, so what we have proved is this, that the maximum value of this guy is 2. That is what we have proved here. But the question is, do we achieve actually the value 2? Okay, well, so for which value of xi's we get 2? Okay, so all xi's must be then half. Okay, for all I. Okay, which means what? For I equals 1, 2, 3 and 4, right? So all numbers are half. Then what is summation xi? Okay, sorry, for all numbers we need them to be 1/4. Okay, then what is summation xi? That is 1/4 plus 1/4 plus 1/4 plus 1/4. This gives 1, right? And what is the square root of summation square root of xi? Okay, so summation square root of xi is half plus half plus half plus half, which is 2. So basically for some xi values we actually get 2, we do get 2, and by this Cauchy-Schwarz this is always less than equal to 2, which means the maximum value of this expression. So the max value of this expression I equal to 1 to 4 xi is just 2. Okay, the maximum value is 2. Yeah, so I hope you understood this, and that's all in this video. If you like the content, do press the like button and subscribe to our channel to motivate us. I sincerely thank you for watching this video.